Hey guys, and welcome to Functional Print Friday. So I pride myself on being halfway decent at solving problems. Working within a tool set to add functionality to something that, I'm not happy with, fix something, make something better, sometimes even create something completely from scratch that solves a problem that, that I have, that either there's no commercial solution for, or the commercial solution is stupidly expensive. I don't know about you guys, but where I fall short is the things that are temporary. It's temporary. That type of stuff where, it's kind of working. It's whatever's in place today it's functional, but it's not great. And I tend to leave those alone until I've suffered the pain enough times where I say to myself, wow, if you actually fixed this, you would have spent 3 times less time than you have the last 3 times this turned into a giant mess because you didn't do it right. And that's where I'm at with this. This is a tablet. And to be clear, the tablet itself is not the problem. It's how I use it. This tablet has 2 lives. Life 1 is for watching videos when I travel. I download a bunch of movies and YouTube videos and all kinds of stuff like that if I have to fly somewhere because I hate flying, and if I can just put my headphones on and disappear into a bunch of creator videos or a movie I want to see, makes the flight go a lot easier. It works fine for that. The other thing I use this for, and some of you guys might already recognize this from past videos on the channel, but the other thing I use this for is TouchDRO, which is the DRO system on my milling machine. And in fact, I 3D printed all the bracketry that attaches the glass scales onto the milling machine. And then I went with a TouchDRO system from, I think it's Yuri's Toys. I'll link the video down below if you happen to be interested in that. And this is my display for that DRO, and it's Bluetooth wireless. So even though I'm like 20 feet from the milling machine, it is actually showing me the actual current position of the table and head on that system. Let's go over there, and I'll show you what the actual problem with this is. All right, so this is normally where this guy lives. Plugged into a charging cable, and it's sort of the flap that goes up over the top, folds into a triangle, holds it upright, and to be fair, it's completely usable in that position. It sits at a nice viewing angle. I can operate all the hand wheels on this machine, still see the display, and that's kind of why I ended up with this temporary solution. I finished all of the DRO mounting on this machine, and I stood it up there and called it a day. And when I was testing it, it seemed fine. Can you guys guess the problem? Yeah, when you're actually milling something, chips fly everywhere. And the really fun part is when I'm milling something that is steel, not only are the chips just bouncing off of this and getting stuck on the soft parts of the case and such, but there's magnets on this that hold that flap in place, so you end up with like a pattern of steel chips just like stuck to all of the magnets on this guy. I've been dealing with this for about a year. I've probably milled stuff that I've used this DRO. So if I don't need the DRO, I'll move it because I've suffered this pain enough times. But I usually do need it. So I don't know, figure in the last year I've probably milled something that I needed the DRO for 20, 30 times. And every time I make a big mess of this, and this is no exaggeration, it usually takes me about 10 minutes just to vacuum up all the chips off of this, because between getting them off the magnets, all the little tiny pieces, and everything that gets embedded in the soft surfaces on this guy, this is like it's almost like an Alcantara or whatever they call that material. Yeah, it takes that long. So I don't do the math. I've spent 4 or 5 hours of my life just cleaning chips off this tablet. Ridiculous. I could have fixed it in far less time than that, but I didn't because reasons. The other day I was standing here and I'm thinking about how to solve this, and I'm looking around in the machine. This side's not great to mount something because there's the crank for the Z-axis, so I'm often reaching up here with my right arm, turning that guy, so anything sticking up like along the side here would be in the way. This side's got this control for the speed and the direction. I could go higher up, I guess, but then I'm looking like way up over here, kind of almost to the ceiling. I thought, well, I got this pole over here. The screen's big enough, that's not so far away, but how would I mount it to the pole? I mean, I could duct tape it to the pole. I could think of any number of ways to mount it to the pole, but I still want to be able to grab this guy fairly quickly for when I'm going to have to travel, or just use it anywhere else. I'm also thinking about setting up a a DRO on the lathe, so I may end up, moving that between the mill and the lathe. I'd probably buy another TouchDRO head and obviously another set of scales, but I think I'd just move the tablet back and forth. I can't imagine buying a second tablet. I could just move it back and forth. And I'm standing here and I'm thinking, you know what? Is the solution right in front of me? Let me pull you guys out of the tripod here. Remember this? We did a video on this a while back. This is not my design. This is a design. I'll link to the original author of this design, but this is a universal phone holder, and it's threaded up here at the top, and there's like a piece that comes down, and it squeezes your phone in these sort of V-ways here, and it's actually got a spring at the bottom. So as this tightens down on your phone, it pushes down on this compresses, and keeps it snug in there without damaging it. And yeah, the tablet's not going to fit in here. Let me grab it. You can see we're pretty far off from that fitting, even if I open this guy up as far as it'll go, which is probably about there. We are, yeah, it would have to be at least twice as big as it is, I think, to reasonably fit this in here. But you know what? Couldn't we just make this twice as big? So yeah, as it turns out, we can. And I gotta say, I honestly laughed when I went down to grab this off the printer because it is comically large. This is pretty much the maximum size I can print on the Bamboo printer. And in fact, it had to be diagonal on the bed to fit. And you might already see some modifications that I made to this design. This was sort of just a proof of concept. It's not gonna work as is, but I really just wanted to see if it was actually going to work in this size. And it does, but not without some issues. So just to show you here that it is actually going to fit, I'm not going to open the flap, but let's see, we got to assemble this guy first. This goes, if I recall, this piece has to go on, and this slips over at the end. Yeah, there we go. Well, you know what, let's open it up. I want you guys to actually be able to see the display. And we'll put it like this. All right, so as you can see, we fit in there no problem. We still have some threads exposed on the top. We could actually go with a slightly larger tablet. But like I said, it's not without some problems. The first problem is the spring is way too hard to compress now. We doubled this in size, so this material now is twice as thick. And when you double the size of something, not everything scales in a fashion that makes sense for that design anymore. And this is one of those cases. The spring is now way too stiff. This thing kind of comes down to where it tightens up, and it doesn't get that good of a grip on the tablet, and this guy doesn't want to compress down here any further until I really, really wrench on this. And at that point, I feel like I'm risking damaging the tablet. The other thing is I did try and make some modifications here. I added a hole up here, which you will see in a little bit what I'm thinking there, and another hole down here, and this feature here. I'm going to need one of those up top as well. But let's go over to the pole and just sort of see how this looks. Okay, so here's what I'm thinking. This guy is going to somehow mount on this pole here, and we can swing it around in any direction we want so that it's pointed in the direction that you can see it best when you're standing in front of the milling machine. And it'll be securely, fastened on here, and I can just come on and, turn this. I don't want to drop the tablet, but I can loosen this guy up, grab the tablet out of here, and I'm good to go. But we got a couple problems to still solve. First of all, the way that we operate this holder is with this big nut at the top. And see, if I just try and zip tie this guy to the pole here, our nut is just going to hit right against the pole. That's not going to work. And we also don't have a ton of surface area. The amount of, let's pretend this nut's not here. Just pretend this guy tightened down in some other fashion. There's not a lot of surface area here and here that would be in contact, because this is a fairly thin part, thin in this cross section here. And this is not only padded, but it is round. So you have a very, very small contact point. So this guy is, no matter how tight we make this, it is going to be wobbling around on this pole. So I've got some ideas on how we solve these problems. Let me go work on that, and I will bring you guys back when I have some design stuff to show you. All right, and here is where I landed on this. I didn't hit the record button while I was doing the actual design work. This one is kind of boring. It's just me designing, sort of add-on pieces to something that already exists and adjusting all the clearances, but I will walk you through quick. So first of all, this is my attempt to just model the surface of that weird carpet padding on the pole. And I needed this diameter so I could match these feet here that come up on the pole. And these notches here in both the base of this as well as up here on the top are designed for zip ties to come around this part, through this part here, and then around the pole to hold this guy firmly top and bottom. And the other reason I wanted to actually model this is so I could figure out how much clearance I needed here with this for this nut. I have this guy in the position where it is going to be closest to the pole. And what this doesn't account for is any squish in the foam as I crank down on these zip ties. So that's why I left that gap bigger than I think I'm really going to need. The other thing I had to do was when I did that test print of just doubling the size of everything, I didn't realize, I shouldn't say I didn't realize, I didn't take into consideration that by doubling the size of every part, I was also doubling the clearance between all the parts. That didn't end up being an issue for the thread and the nut, but it did end up being a difference for all of the sliding parts. And as I mentioned already, that spring. So inside of here, if I hide this, I'll hide the pole. Inside of here is a sliding piece. This actually moves downward when this is pushed on by the tablet in this case as the spring compresses. And it serves a couple of purposes. The side to side in this axis, it keeps this guy straight in that axis so that it can't turn like all wonky to one side. And also in this axis so that this guy can't bend just in this direction. You can imagine with this V here, if this guy just bent outward, particularly if we had some creep in the material, eventually this guy could open up enough that it wouldn't actually retain the tablet or the phone that it was originally designed for. This also, you can see this doesn't come all the way through. This sliding piece contacts up against the top. In fact, it's a V in there as well to keep it from rotating in that axis. Up here at the top, I had to adjust the clearance for this guy as well. I had to thicken up this section down here and then tighten up the clearance in here as well so this guy didn't rock around so much on this top portion. And basically, I positioned everything here so that it is as short as it can be and as short in length overall, because this guy has to fit on the bed of the Bamboo P1S or X1C. I still don't have a large format printer, and this is about as big as I can go, but also maximize how far this nut can move up to maximize the space in here. I know I'll clear this for the tablet that I have, but just kind of keeping the future in mind. If that tablet wears out, I end up getting something slightly bigger. I'm going to want that to fit in here as well. And you can see I've calculated, there's a little bit of gap here still, but this is about as far as I can crank this until the nut hits this, our foot here that raises up from the pole. And this guy would slide up here into our zip tie. That zip tie is going to obstruct this guy from coming out any further. So I think this should work as is. Oh, the other thing I wanted to mention is if I hide, I'll hide this main body. You can see there are basically some pegs coming off of these feet here that go into those holes that you saw in my initial test piece. So if I hide one of these now, you can see those pegs are fitting into these holes here on the bottom. That's just going to keep this guy from, we're not counting on just the zip tie to hold it all together. That peg is going to keep this guy from slipping down off of those feet, and same thing for the bottom. All right, let's print it out. All right, and here is our updated main body part, and you can see we have grooves up here for the zip ties now. There is all the clearances that were tightened up down here. Now keep this guy from going too far off center if you try and bend it in just one direction, or twist it, I should say. And our smaller cross section of the spring down here is way, way better. I can flex this guy no problem now. So I think that is going to probably grip our tablet very nicely. And actually, let's compare it to the original one. Yeah, so you can see compared to the first one here what a difference that made on that spring section. And you can actually see, I think you can see a difference in the clearance here as well. You can see how much tighter this is versus this guy down here. And lastly, our standoffs. And why do we have 4 of them instead of 2? Well, let me tell you, I made some poor decisions on placement on the bed of these. At first I thought, well, I don't care about this bottom surface at all. It's going to be against the pole, so I'll just print it standing up and have supports underneath. Well, that didn't quite work out. Both sides broke off, and you can see it just, I'm actually surprised it managed to start printing cleanly again when this broke off and there was just nothing there at all. So it looks fine on the top, but you can see that's not going to be usable as is. Then I thought, all right, well, that's not the end of the world. I'll print it standing up this way, because I also don't really care about this face down here and this face. And I figured the angles on these would work without supports, and yeah, they kind of did. This one's usable. Maybe I'm being too nitpicky, but I'm really not a fan of how this stuff came out. It's too steep of an angle to print unsupported. It came out pretty messy on both sides. And I went with what to me was the least obvious way to print these, and that ended up being the best by far. I just printed them with this face down like that, which means I'm then supporting basically our peg here, as well as our pockets on the side. And I turned tree supports on for all this, and look how clean this came out. Like, I feel silly wasting my time trying to print it in the other orientations, because honestly that looks great. And here's the other one. Same thing, we'll just break the tree supports off. Yeah, look at that. Same thing. It's almost perfectly clean everywhere. I might have a little bit just right there at the bottom where that tree support came up to touch against that surface. Actually, let's test fit it before I trim it. Actually, no, that's perfect. If I actually trim that little bit of mess, it's probably going to be a little bit loose. Like right now, it's like a perfect friction fit. You can see it holding position on there. If I trim that, it's going to be loose and fall out, which wouldn't be so bad. I mean, this thing's going to be held with pressure against the pull anyway. We got to line these up. This one, I think, goes this way to line up with the slots in the front for the zip tie, and this one goes this way. All right, that's looking good. In theory, I think we have our clearances right. I can see that nut should spin and be clear of where that pole is going to be. Now, I don't know how much this is going to pull into that foam. This seems to be a pretty decent sized contact patch, so I don't think it's going to like compress that foam a whole bunch, even when I tighten it down enough to be rigid on that pole. But let's go see. Yep, that definitely clears. You can see there. Well, hopefully you guys can see. I can't see the screen on the camera anymore. But we've got, looks like even if I pull that in as tight as I can, I'm still seeing like ½ an inch clearance back there. So we probably could have gone even tighter with that. Let's get some zip ties on this. I'm not sure exactly how high I want to be on this pole. I think I'm going to have to put it up here loosely and then sort of stand back and see what makes sense. All right, that's tight enough that I don't think it's going to fall off. Pop this guy in here. Is that going to stay? Maybe. I feel like I'm really pushing my luck with this. I'm going to tighten it up a little bit more. Yeah, I think that's going to stay. That's actually pretty good for height. Angle's wrong. We got to come around more. Okay. You know, that's probably good from a height perspective. So here, I'll move the camera up. That's my eye level. And it might look a little on the low side. Here, if we walk over to it, yeah, it's probably about maybe 16 inches below eye level. But everything else I'm doing over here is below eye level as well. I'm going to be looking down, operating the controls on this. And if I get too much lower, I'm liable to be in the path of chips again. Particularly if I have like a fly cutter in here. Those things throw chips everywhere. And the head on this milling machine isn't all the way up. In fact, let me put the head all the way up. All right, that is the head at the maximum position. I mean, I could crank higher, but we wouldn't have full contact on the dovetails. So let's see, get down to the level of Yeah, if we go any lower than that, it's still going to be getting hit with chips. And I mean, it's not that often that I'm going to be milling something at the maximum height of this, but still, I think that's a good reason not to go any lower with it. Now, one thing I didn't think about is I do walk through this space. This is sort of like a, sort of my path to this other side of the garage, between the lathe and the milling machine. And it does kind of stick out now. I could see walking into this, but you know what? Yeah, I think we could just go off center with this guy. It's probably not rigid enough now because I'm only attached at the top and loosely. But yeah, I think we can just bring it off center, and that's completely going to clear here so I don't walk into it. All right, let's get this actually strapped up to this pole so it's nice and rigid and just see how everything feels. All right, in typical fashion for me, I think I moved this guy up a little bit and then down a little bit and up a little bit and down a little bit, probably 10 times until I was perfectly happy with it. But hey, if I'm going to wait this long to fix this thing properly, I may as well take the time to get it right. And if I end up not liking the position, I can always just cut these zip ties and start over again. But even with this guy cinched up really tight, you can see the zip tie pulling on the foam here. There is still plenty of room for this nut here. I don't have the full 1/2 inch like I thought I did. If I bring that around to where it's closest, it is actually almost touching, but there is still plenty of room to turn that guy, and I can crank down a good amount of tension on this now with that spring absorbing it and keeping it in place. And the display is, what am I doing here? Must have touched something. There we go. So this is now nice and stiff, even with this big offset to the side here so that I have a clear path through here without bumping into this. I have, I can knock this guy solidly and, not move the display, which is great because there is a lot of button pushing in the course of using this thing. And probably the best part is, even though this guy is very rigidly mounted to this pole and in perfect viewing of where I'm going to stand operating this machine, I can still very easily just unplug that right angle cable, give that nut a quick twist and pull this guy right out and travel with it. And something else I hadn't even thought of, when I orient it this way with the charging cable on this side, the power button is also right here. So I don't keep this guy on all the time. So the power button is super easily accessible. I can just, with one finger, tap on that button. This guy turns back on, and I am ready to go. So I think I'll probably end up doing something similar over here for the lathe as well if I do end up putting a DRO on here. There's no pole here, so it's not going to mount that way. But what I'm thinking is maybe like an articulated arm coming off maybe the end cover here, the gear case. I don't want to drill into this because that's the casting for the head, and this is oil filled. But this is just a steel cover. It's hollow on the other side. There's plenty of room inside here for nuts or whatever. So maybe have an arm coming off of there and have it just positioned kind of just up here. In fact, I think I have, I have this guy. I think I picked this up at an estate sale. Figured I'd do something with it at some point. This is made by, this is actually Panavice that makes this. I don't know if they still make these, but this has 2 ball heads. So this piece could be mounted maybe like down like here, and then maybe mount this to, I don't know how we do that. I guess we could design something that attaches to sort of the center point here. I don't want to come off the bottom because then it's going to wobble. If we mount from the bottom, it works fine for the small one here on the tripod that now you guys can't see for the phone. But as tall as this is and as heavy as this tablet is, I fear even if we have a solid mounting point from the bottom, this guy is still going to wobble back and forth when we push the buttons, and that's not what I want. So yeah, expect a future video at some point of how we make another version of that same type of holder for the lathe. Guys, as always, thanks for hanging out in the shop with me for this week's design. I am really happy with how this came out. I can't believe I waited this long to do it. But you know what? I don't know. If I tried to solve this earlier, I might not have come up with that idea of just doubling the size of an existing design and sort of adding that feature to pole mount it. I can't think of a better way to do this. If I'm missing something even more obvious, please feel free to let me know down in the comments. But I am really happy with just how rigidly that mounts on there. And I learned a lot about scaling designs. I mean, my initial thought was, I'll just double the size of this thing and call it a day. And there's a number of things that we had to fix on this design. Everything from basically the spring rate, which is controlled by the thickness of the plastic, to the clearance of all the parts, because just because we doubled the size doesn't mean that we need to double the clearance. That just created a bunch of slop where we didn't need it. So, guys, thanks for tuning in. If you enjoyed this video, I do a new functional print every single Friday. If you're into that, hit that subscribe button. And if you do, I'll see you next Friday.